Welcome! In this video, we are going to look at problem 6 from chapter 21 of College Physics by OpenStax. Okay, so we have a 48-volt battery and two resistors. One has 24 ohms and one has 96 ohms. We need to find the current and power for each when they are connected in series, and then we need to repeat when they are connected in parallel. So let's start a list of what we know. And we know we have a battery that has 48 volts. We'll say R1 is the 24 ohm resistor and R2 is the 96 ohm resistor. Okay, so we need to connect these in series. And so what we can do, so we can put our battery here. We'll make R1 there, R2 there, and then back to the negative terminal of the battery. All right, resistors in series add. And so what we can say is that R sub S for R series is going to be R1 plus R2. So our R series is going to be 24.0 ohms plus 96.0 ohms. So the equivalent resistance, which is we're using R sub S for R series, is 120 ohms. Okay, so now we can find the current in each. And the way we will do that is by using Ohm's law. Okay, now because they are in series, they both have the same current. And so we can use Ohm's law, V equals IR. We just need to solve that for current. So all we have to do is divide both sides by the R. That gives us current is voltage over resistance. So our current is going to be the 48 volts over the 120 ohms. Gives us a current of 0.400 amps. And so that is the current in each resistor when they are in series. Okay, now we need to find the power. So find the power for each of them. And so what we can say is that power 1 is going to be the current squared times resistor with resistance R1. Okay, so our power 1 is the 0.400 amps. Square that and multiply by 24.0 ohms. So the power in resistor 1 is 3.84 watts. Okay. And then power 2 is going to be I squared times R2. So power 2 is the 0.400 amps. Power is in amps. We're going to square that now by the 96.0 ohms. Okay. And so power 2 is going to be 15.4 watts. So there, when they're in series, we found the current in each and the power in each. All right, now let's consider the case where they're parallel. And I think I'll just go to a new sheet. So we'll say B parallel. Okay, so we have our battery. We'll put R1 here. And we'll put R2 over here. So now they are in parallel. So this means they each have the same potential. Okay, so current I will come out it gets to the junction where the wire splits and goes off to R1 and R2. And so we can say R1 will get current I1 and R2 will get current I2. Okay, so now we need to use Ohm's law to find current. So use Ohm's law to find current. Okay, and so we had found before that current is voltage divided by resistance. And so I1 will be V divided by R1. So I1 is going to be the 48 volts divided by the 24 ohms. So current 1 ends up being 2.00 amps. Okay, current 2 is going to be V over R2. So current 2 is the 48 volts divided by the 96 ohms. Current 2 is half an amp, so 0.500 amps. Okay, let's find the power in each now. All right, so we can use power 1 is equal to I1 squared R1. And so power 1 is going to be 2.00 amps. We're going to square that, and then we're going to multiply by the 24 ohms. So power 1 gets more current because it has less resistance, and so it has a power of 96.0 watts. Okay, power 2 is going to be I2 squared times R2, and I2 is half an amp. Square that times the 96 ohms. Power 2 is going to be 24 watts. All right, and so there are the two currents and the two powers for each resistor. I hope you found this informative and that you enjoyed the video, and I will see you in the next one.